starting now. Good afternoon and evening to everybody, and welcome back to TezAsia Hackathon 2022. I'd like to invite Anshu from TezAsia. He's a contract engineer that will be teaching you how to actually build a front end of a dapp by integrating with Taquito.js. So without further ado, I would pass the floor to Anshu. Thank you.
Thank you, Brian. Is my screen visible, Brian?
Yes, I'm gonna add your slides now.
Mm-hmm.
I can
Yeah,
see your screen. Yeah, I can see your
awesome.
slides. Yeah,
Okay, then I'm starting.
yeah.
Okay, a very good evening once again to everyone. And this will be the final of the three-part session of building a complete dapp on Tezos. In the first two sessions, we understood how to write a proper smart contract on Tezos, and we ended up making a lottery contract. And in this session, we will be actually making a front end for the lottery contract. And for that, we'll be using a really popular library called Taquito. So like every time, here's the link for the resources. So please bookmark this if you want to keep a track of all the videos and all the slides that I have used in the past sessions. And one thing to note that for today, I am assuming that all the watchers are already aware of React.js and at least know the basics because the front end will be written in React. So what are we making today? Well, I already told you, we will be making a front-end application for our lottery smart contract. And using this front-end application, we can actually buy tickets and also end the game because those are the two operations that our smart contract can handle. And we will be using Temple Wallet to actually sign the transactions that will be going onto the blockchain. So now, how do we actually connect a front end to the blockchain? How does it all work? Well, from a top level view, what we do is we connect to one of the nodes in the entire network. If you have been here since the first workshop, then this is something I explained. So usually the transaction is sent to one of the nodes, and then the node floods the entire network with the transaction object. So similarly, in this case, what we will do is we will connect to a Tezos node, which is provided by SmartPy. And specifically, we will be connecting to a Jakarta net node. That's a test net on Tezos because for testing purposes, we deploy the contract on a test net instead of the main net. And the way we make this connection with a node is using Taquito. So Taquito here is used to make the connection and also to send these operations onto the node. So now you might be wondering, like, why are we using this library? Is there like a way to do it right from scratch? Well, there is, but it's really tough. So what is usually done without Taquito would be we have this transaction object, and we create this object wherein the first few fields look very similar, and the last field, that is the parameters field, is the parameters for the function that we are calling in a contract. And this parameters field is the most tricky one because this requires a Michelin expression. Now on Tezos, as I told you, everything goes down and compiles down to Michelson. So we need an expression that adheres to Michelson to be passed as parameters. And that is quite difficult to construct. And it doesn't end here. We have this transaction object, then we basically convert it to signed bytes. Signed bytes basically means you first convert it to bytes and then you use a wallet to sign it. And finally, we post the operation to a Tezos node. So basically, you can post it on this endpoint. You put the RPC URL, which would be similar to this, and then you basically inject the operation onto the blockchain. Now, this is actually tricky. But with Taquito, you don't have to do anything. You basically have a contract instance. And then this is very Web3 way of doing it. If you are coming from an Ethereum and you have used the Web3 library, then you can relate to that. So we have a contract object. We use the methods field, which is injected into the contract instance by Taquito. And then we just refer to the entry point that we want to call. So in this case, I have this random entry point called add items. But let's say in our case, we will use the buy ticket or end game entry point. And then we just pass in the parameters and append a dot send, and the transaction goes onto the blockchain. It's really that simple. It does require some setup before this, but that's just that's not very complicated. And this entire process is squeezed down to this one single line. Now, behind the scenes, Taquito obviously does this. It basically does this and constructs all those expressions for us. But on the front end, we just have to use this one line for sending operations. So in the last workshop, I wrote and deployed this lottery contract. Now, last day I just made one transactions, but I was testing it out, so you can see like plenty of transactions here. But it's the same entry, it's the same contract, where you can see I have the two entry points buy ticket and end game. And here's the storage. So I have like a couple of players already in the storage, and 3 tickets are remaining to be sold. And we will be actually selling these 3 tickets from the front end today. So let's get started. The first thing that you have to do is clone this repository. So I've basically made a very concise boilerplate. Okay, the link is incorrect for some reason. I'll just fix the link. It should be my GitHub repository. Okay, so now the link is fixed. So I've written some boilerplate code for you to just start using. It's basically a very simple React app, and I've set up some state variables and a very basic UI, which I'll show you now using Bootstrap. So I have already cloned it on my machine. If you're aware of, if you have some experience with React.js, then you will obviously understand what's going on here. Just a simple component with some Bootstrap CSS and a few utility files, and just one proper subcomponent, which is a navbar. So the first thing that I have to do is I'm already in the repository, and I'll do npm install to actually install the dependencies for the boilerplate. And if I go to package.json, technically there are just 3 extra dependencies that you have to download if you are setting it up on your own. It's the Taquito library, and then it's the beacon wallet interface provided by Taquito. I will explain what exactly it is. And then I have the Axios library just for making HTTP requests. Nothing else, that's all. So my packages are getting installed. So yeah, the packages are installed. Now, if I have to start the React server, I do npm start, and a React server will get started on localhost 3000. And right now you see it's a very simple application, just 2 buttons and a really simple UI. Now, right now the buttons obviously don't work, and we will be adding functionality to these buttons. So before I write the first line of code, are there any questions in the chat box, Brian?
No, so far there is no questions from the audience. Yeah, you can
Awesome.
continue. Yeah, thank you.
Okay. So the way I've structured this boilerplate is that I've added these to-dos so that if you are following along either in this tutorial or later if you're watching the recording, then you can follow along really easily. So let's start with the first to-do, and that is setting up the Tezos toolkit. So Taquito provides this class called Tezos toolkit, using which we first initialize which node are we actually wanting to connect to. So in this case, as we saw on the slides, we want to connect to a Jakarta Net node provided by SmartPy. So to do that, first we import the Tezos toolkit, and then This Tezos toolkit instance is usually just given the name Tezos with a small t. And within the parameters or the constructor parameters, we pass in the URL of the RPC we want to connect to. So in this case, that would be the Jakarta net node of SmartPy. Now make sure that the URL is correct. It's jakartanet.smartpy.io, because if your URL is incorrect, Taquito won't know which node are you actually trying to connect to. And you should export this because we will be using it in other places. So that's it. It's a very just 2 lines of code, and you have a Tezos toolkit instance with you. Now the next thing we have to do is set up a wallet instance. Now in Tezos, we have this incredible thing called the beacon wallet interface. What it does is that it provides a common interface using which you can connect to almost all the wallets on Tezos. So that's why if I go over to something like KipoSwap, which is an application on Tezos, and if I click on connect wallet and I click on beacon, then you see I get this pop-up where I have options of almost every wallet on Tezos. So basically we want to get this pop-up on our application too. And to do that, the first thing that we do is set up a beacon wallet instance. So first import beacon wallet, and this is what you get from Taquito/beacon wallet. And then create a beacon wallet instance. I write new beacon wallet. And for the constructor parameters, the first thing I pass is a name. And this is the name of my application. So let's say if I want to give the name something like Tezos Lottery dapp, I could give it. It's very inconsequential, so you can just give any name that you want. And preferred network. This is really important. So you need to tell Beacon Wallet which network you want to connect to. So in this case, we want to connect to the Jakarta testnet. So I will write Jakarta net in the preferred network. And that's it. We have a wallet instance, and we will export this to. Now we actually need to use this instance and connect to the wallet, right? This is just a wallet instance, but we need to connect or have the user connect to it. So to do that, I have set up connect wallet function here. And in this connect wallet function, we will basically request the permission to connect. So in this case, when I am clicking on connect wallet and then on beacon, then this pop-up is requested. So that is what we do in connect wallet. And the way that is done is you write await wallet dot request permissions. And in here, you have to mention on which network do you want the permission to be. So in this case, the way you do it is network type, and in type we pass in Jakarta net once again. Now, when we call this function through one of the buttons on our front end, then we will get this pop-up and we can select whichever wallet we want to connect to. Now, once we are connected to the wallet, so I'll show you when I connect to the wallet. Then the first thing that I get is a request to choose one of the accounts. So here you can see it is connecting to mainnet, and I'm getting a request to choose one of my accounts. So after choosing an account, here you can see the account is loaded. So this loading needs to happen. And to load the account, we need to get which account the user actually chose, or which account is the active account. So the way we do that is we get the active account through wallet.client.getActiveAccount. Now, it might happen that the user is yet to select an account, and in this case, the active account will just be like an empty string. So first we have to handle the case where it's not an empty string. So basically, if we have an active account, then you return active account.address, because as you can see on KipoSwap, the address is being shown on the button on the connect wallet button. So we need the address of the account, else we just return an empty string. Pretty simple. That is it. This is the only beacon wallet setup that you ever have to do in any Tezos application. You might have some extra stuff like disconnect wallet or change accounts, but if you're making like a very basic applications, this is the entirety of the setup. And finally, after setting up the wallet, you actually have to let Taquito know that this is the wallet that I will use to sign the transaction, because Taquito just takes a transaction and it puts it onto the blockchain, but we have to tell Taquito how are we actually wanting to do that. So what we do is we set a wallet provider on Tezos. Set wallet provider, and we import the wallet instance. And we have a complete wallet and Taquito setup done. Before going further, are there any questions? Brian?
Oh, okay. But a user has asked which
Mhm.
wallet do you think is best for to use on the Tezos blockchain?
Well, so if you want a wallet that works in the browser, as a browser extension, then Temple Wallet is the best. If you want a wallet where you can sign in using traditional OAuth like Twitter or Google, then you can use Kukai Wallet. In Kukai Wallet, you can actually sign in using Twitter. So this is a great thing. And if you want to use a mobile wallet, we have something called Nan Wallet, which is an incredible wallet being made at Tezos. So you can even use that. So it depends upon your utility at the end. But yeah, in today's session, I will be using the Temple Wallet.
Okay. Okay. Thank you. There's no more questions. You can
Awesome.
continue.
So now that we have the wallet set up and Taquito set up, if I go back to my application, right now I can see if I click on the connect wallet button, nothing happens. So I need to connect all this elaborate setup that I've done to the connect wallet button. So I go back to my navbar where the button actually is, and I call the connect wallet button, the connect wallet function in this on connect wallet function. So yeah, the naming scheme is that I have the primary functions are just called is just have a name, and the secondary functions in the UI are then appended with an on. So that's the usual naming scheme that I'm using. So to connect the wallet, I will first import the connect wallet from the utilities folder, and then I will just await connect wallet. Now here you can see I have set up this account state variable. So after connecting to the wallet, I actually need to get the active account and put it in this state variable. And the way I do this is that I have a constant account variable, and I get the account from the get account function. Once again, it is auto imported. And then I use this set account function provided by use state hook to set the active account. Now, the on call connect wallet function actually needs to be called when the connect wallet button is pressed. So here you can see this is the connect wallet button. And there is also a to-do that I've written for your simplicity. So if I write on click, then I pass the on connect wallet function as a callback in here. Now, if I go back and I just refresh the page and I click on connect wallet, there you go. I have a pop-up. Now, right now I'm getting the Temple wallet pop-up because I apparently connected before. So if I reset the connection and click on connect wallet again, there you go. We have our beacon wallet pop-up. And now if I click on connect wallet, I will be given another confirmation pop-up. Now let's say I choose Alice and the account is connected. But right now, even after the account is connected, you see we are not seeing which address is actually connected. So to get the address, what we do is we use the account state variable. I'm using the word account and address interchangeably. Both kind of mean the same. Account is actually a superset of address. It has more stuff into it. So to do that, the way I do it is, here I have the connect wallet text. I wrap it in curly braces and I make it a string. And I use a ternary operator. Now you will be using ternary operators a whole lot whenever you're building a dapp or a decentralized application. So I basically check if the account is not an empty string, then I show the account. So this basically means that I do have an active account or that the wallet is actually connected. So in this case, I'll show the account, which is the address. And if I don't have an account, then I just show the connect wallet button. Now, if I save it and I go back and I refresh the page and connect wallet again, there you go. I now have the account address in here. Now, if I want to change the account, then what I can do is I can just re-click it. I can select Alice, click connect again, and then a new account is selected. So this is really flexible if you use state variables properly. But right now there is a problem here. If I refresh the page, my account connection is lost, or rather I don't see the active account anymore. And this is obviously not ideal because and every time the page is refreshed, you can't connect the wallet again, right? It's a lot of steps. Now the thing here is the wallet is connected under the hood, but the UI is unable to catch it, or we are not expressing it properly on the UI. And the way we can do that is using a use effect hook. Now this use effect hook is just executed once whenever there is a page load. So what we can do is whenever the page is loaded, like a fresh load is there, we can just fetch the active account and set it as the account state variable, right? So in here, I will just fetch the active account. I'll set it as the value of the account state variable. That's it. Now, it doesn't matter how many times I refresh the page, it will stay to the wallet that I connected. Now, if I change the wallet and let's say if I choose Bob, the address has changed. And if I refresh, then it stays connected to Bob's wallet instance. So this is like a must in your dapp. Make sure you do this because it is really not ideal that the page loads and you lose the connection. Any questions popping up in the chat, Grant?
No, not
Okay,
for now. Thank you.
awesome. So now the first step is done. That is, we have activated the connect wallet button. Now, let's go and make something out of the buy ticket function. Right now, if you are clicking on buy ticket, nothing is happening, right? So we want to make this functional. And the first step into doing that is writing out this function, which actually injects an operation into the Tezos blockchain using a Taquito Tezos Toolkit instance. So how do we do this? Well, the first thing that you do is you write a try catch block. This is really important because we are using an await call in here. So ERR. The first thing that you have to do is initialize a contract instance. And to do that, you have to use the Tezos or the Tezos toolkit instance that you originally exported. So here it's auto import. Then tezos.wallet.at. Now what tezos.wallet.at does is it takes, I'll provide the contract address in here. So it searches for the contract instance on the chain, for the contract on the chain, and then creates an instance and puts it in this variable. So if I go to my slides, I can get the address of the contract. I'll paste this here. Now, after my address has been pasted, I have the contract instance. Now, to actually inject an operation, what we do is await contract dot methods dot. Then, after these two words, what we do is we refer to the entry point that we want to call. So in this case, we want to call the buy ticket entry point, which is buy underscore ticket in our contract. If you remember, there were no parameters. And then I write send. Now, if you remember correctly, then we also have to send some Tez from the front end to the contract. And to do that, if you want to send any Tez from the front end, you do that in the dot send appended function. And in here, you write amount. And remember, we have to send one Tez. Now, if I want to explicitly tell Taquito that this is a Tez value and not a mu Tez value, then I have to write mu Tez equals false. Because otherwise, if I don't write mu Tez equals false, or if mu Tez is true, then in this case, I have to basically put 6 zeros in here, because 10 to the power of 6 mu Tez is 1 Tez. So both ways are correct. It depends upon which one you are comfortable with. So in this case, I will write amount 1 mu Tez false. And this thing needs to be assigned to a variable, and by convention, we assign it to OP, which means operation. Now, at this point, the operation is injected onto the blockchain, but now we have to wait till the operation is actually confirmed, right? So to do that, we do op.confirmation, and we pass in 1. The 1 represents that it waits for at least 1 block after the operation is confirmed. Because ideally on Tezos, it takes 30 seconds for the operation to confirm. So we need to show the user some kind of a UI response, so the user knows that, yes, my operation is injected, but it's in a pending state. So this is really important if you want that to be shown on the UI later on. So that's it. In this little code, we can actually inject an operation into the blockchain. And if Taquito wasn't there, we had to do so much. First construct this object, and then convert it to signed bytes, and then post it onto a specific URL. But with Taquito, very comprehensible and very concise. So now let's go to the app.js file and actually make use of the buy ticket operation. And the way we do that is, once again, in here, I have an on buy ticket function, which needs to be called when the buy ticket button is clicked. So in here, the first thing that we do is we call the buy ticket operation. Now it's again auto imported here. So I'll just give it a comment. So we'll call the buy ticket operation. And then the on buy ticket will actually be called when there is a click event on the buy ticket button. Now, sometimes people just tend to leave the app here, but this is not ideal. This will work, and I'll show you it. I'll give you a proof that this will actually work. So if I refresh the page and I click on buy ticket, then I'm getting my pop-up. And it is also asking me to confirm the transaction. So if I confirm it, then the transaction is actually submitted. So here you can see successfully submitted operation. The operation is submitted onto the blockchain, but I don't have any response that my operation is pending. If I check it out here on Temple wallet, then in activity here you can see, I guess they don't show the pending status here, but since this operation is pending, there should be some kind of a UI response that, yes, the operation is pending, it's yet to be confirmed. So to do that, let's wrap this in a try catch block once again. And here, if you scroll up, you see on line 13, I have defined a loading state variable, and we will use this loading state variable to actually give a UI response. And this is a Boolean variable, and you will soon know why it's a Boolean variable. So just before we send the operation, let's set loading to be true. Now, if once we set loading to be true, what we can do is in here where we have the buy ticket button, we will do something similar to what we did on the connect wallet button. We will wrap this in double quotes and make this a string, and we'll use a ternary operator. So if loading is true, then instead of showing buy ticket, we show loading. Otherwise, yeah. If it's true, we show loading. Otherwise, we show buy ticket. Now, once the operation is actually over, we need to revert it to buy ticket, right? We just can't keep showing loading. And to do that, we can, after the operation is over, we can just write loading, set loading as false. Now, sometimes people do end up leaving this here, but there is a problem, and that is, what if there is an error in this transaction? If there is an error, we straight go to the catch block, right? And set loading false is never executed. So it keeps showing you a false. It keeps showing you a loading uh, text on the UI. So to get this right, we should put the set loading false after the try catch block, because in this case, this line is hit. It doesn't matter whether the transaction fails or not. This line will get executed. And apart from this, now if the transaction is actually confirmed, we need to give the user some kind of an alert that yes, your transaction was confirmed. So in here, we will do alert transaction confirmed. Now, obviously, if you're making a proper application, you can give like a proper model, a beautified model. And if there is an error, then we can give a different kind of an alert, that is transaction failed. And we can give the error message, which would be err.message. This is like a very standard way of doing for every single dapp. So it doesn't matter what you're building. These are some of the steps that you will be doing whenever you are injecting a transaction onto the blockchain. So now if I go back and let's refresh once again, and if I click on buy ticket, and click on confirm, now this time you see I have a loading, and well, this was fast. My transaction was confirmed immediately. And if I go ahead, if I go over to the to the block explorer, and I check, you see this is the previous transaction which I sent here, and this is the current transaction that got confirmed just 15 seconds ago. And in my storage, initially I had just 2 players, now I have 2 more. It's the same account, but then yeah, we have 2 more entries in the players mapping, and we just have 1 ticket available. So in just a few steps, we activated the buy ticket function, or the buy ticket button, sorry. So now, well, you see, if we go over to the block explorer, we can obviously see all the players, but we must be able to see the players here too, like which ticket belongs to which player, because everything is open on the blockchain. So we must also show which player has how many number of tickets. So here you can see I've set up another state variable called players, and another state variable called tickets. Now, the tickets state variable is being used on this line. It's a simple div that shows the number of tickets remaining. And the players is actually a list. You see, I've initialized it as a list. And the players list is being used here. So right now you don't see that because players list is empty, but we are basically mapping the list and the number of each ticket onto the player's address. If you are comfortable with React.js, then you will definitely understand what's going on here. It's just a simple way to show all the items contained in a list on the UI. So how do we actually get all the information that is present in here from the blockchain? Now, one thing you can do is use Taquito to get it. But in here, I want to show you another way which we often use in a professional development setting, and that is use TZKT's own API to get it. So we go over to the TZKT file that I have in the utilities folder. And before I do anything here, I like to show it to you in the browser itself. So TZKT provides this API for all the testnets, for all testnets and the mainnet on Tezos. So in here, I already have the link in my browser. So the link is basically api.jakartanet.tzkt.io. And then this is just basic standard, which you can find in their API documentation. Then I write the contract address, which is the same as the address I have opened here. And then slash storage to get everything from the storage of the contract. If I click enter, then you see I get a response wherein I get all the players as a mapping and basically everything that's there in the storage. And as you can see, we have just one ticket available right now. So how do we fetch this and put it in our application? Well, it's just easy. We use Axios for that. So I import Axios. Once again, some try catch statements. And it's just the standard way you use Axios. I do an axios.get and I use this link to get the storage of the contract. And as you might know on Axios, if you want to get the response data, you do rest.data, and we will return the data to the caller of the fetch storage function. Now, if I go back to app.js, the next thing that I have to do is use the fetch storage function that I wrote there and fill up the players mapping or the players list and set the value for the tickets remaining. Right now, using the use effect, which is just loaded when the page is loaded, I am setting the players to an empty list and tickets as 5. But here we will fetch the storage using the fetch storage function. Remember to await this because it's returning a promise. Now to set the players, well, here you can see the players is actually a JavaScript mapping. So if I want to set the players, I just want the values. So to just get the values, what I can do is I can use object.values storage.players. And for tickets, I can just go with storage.tickets available. You have to use the exact same field names as it's given in the storage. Now, if I save this and go to my application and I reload the page, well, it's not appearing here for some reason. Let's check what mistake I've made. It's undefined for some reason. Let's see. Okay, sorry, I forgot to await this here. Now, if I go back here, there you go. We have the addresses of the individual buyers of the tickets, and we also have the correct value for the number of tickets actually remaining in the system. And it doesn't matter how many times we refresh it, we get that every time. So now that we have the buy ticket button working, and we also have the number of tickets remaining and the players being displayed. The next thing that we do is we need to activate the end game button too. So right now we have one ticket left, and if I end up buying that ticket, if I click on confirm again, and transaction is confirmed really fast. So here you go. Here you can see the end game button is activated. And the reason for that is I've set it up in a way that if the tickets is greater than zero or tickets available is greater than zero, then I end up showing the buy ticket function, buy ticket button. Otherwise, I just show the end game button, which is not functional right now. So if you click on it, nothing really happens. So we need to make the end game button functional. So the process will be very similar to the way we made the buy ticket button functional. We go to tzkt, sorry, we go to the operation.js folder. I'll just copy paste everything that's there above because most of it is very similar. We need the contract instance, and the way we send the operation is almost the same. Now, in this case, you're not sending any money to the contract, so we just remove everything from .send. And instead of buy ticket, we use the end game entry point. Once again, the confirmation remains as 1. If I go back to app.js, here I can put the same logic that you can see in here in on endgame. And this is one thing that is like really common amongst every single function that you will be right that is sending an operation. You set the loading value to true, and then you send the operation, and then you show some kind of a pop-up. So there will be a lot of copy pasting even when you are making your own decentralized application. And in here I can just change it to the end game operation, which gets auto imported. Now I just need to call this, and I can call this through an on click event on the on click button, on the end game button, on end game. And similar to how we did the loading check in here, we will do it here too. Let's replace it with end game. Now if I go back, let's refresh, let's click on end game. And before I send the operation, just to know who is the eventual winner, I'll show you the actual balances. So Alice has 57 Tez and Bob has 21 Tez. And whoever wins will have 5 Tez more, because as we learned in the lottery session that the entire amount gets transferred to the winner. So now if I go ahead and I confirm the transaction on Temple, and wait for some time. And transaction is confirmed. Now if I load the page, well, it's all cleared because the game is reset. If you remember, at the end of every lottery game, the game is reset. But if I go over to my Temple wallet, here you can see Bob is the winner. Bob now gets all the 5 Tez that was in the contract. So instead of 21, now it's 26. So that is actually it. It doesn't take a whole lot of things to make a decentralized application. You can make the UI very beautiful, and that is most of the work. But to actually connect it with the blockchain, sending operations, it's like really, really easy. There are a few things which are left to be discussed. So before that, Brian, any questions?
No questions so far. You can continue.
Okay. So that was it with the coding part of the application. Now, if you guys want to see the complete code, then you can go over to the lottery dapp complete repository where I have the complete code that I write here today. And apart from that, I've also hosted the application here. So in case you just want to try it out, you can check here. Well, this is a different contract, so it's the data is different, but the code is the same. So what could be the possible improvements in this entire dapp that we built across the last 3 sessions? Because, well, nothing is perfect and there's definitely a whole lot of scope for improvements. And the first thing is that players should be able to buy multiple tickets at once. Right now, as you can see, we have to call the buy ticket function every time the player wants to buy a ticket, which is not ideal. So if a player wants to buy like 5 tickets all at once, then they should be allowed to do that. Then record the winners of each lottery round. So right now you can see once we click on end game and we refresh the page, it's just back to the uh, previous state. We don't really get the winner, or we don't see who actually won the lottery. We can just go over to our temple wallet and then we have to figure it out. So ideally you need to have some kind of a recording system, whether you can have it in the contract itself or you can set up something called indexers. So you can have like a small backend which checks for the winners every time. Apart from that, you can even go ahead and make something like a buying of tickets using FA 1.2 tokens. So you can use like some stable coin to buy the tickets. This is like a great addition if you want to try it out. And lastly, you can even give the lottery ticket as an NFT to the user. Right now, there is the lottery ticket is not really a ticket, it's just the player's address being added to the map. But you can go ahead and make it more complex and more functional by providing the an actual ticket in the form of an NFT to the user. So these are some things you can even do in the as a part of this hackathon, because like this is considerable amount of work. So if you want to make a better version of this lottery game, you're welcome to, but make sure you have to add like all 4 of these and have like an incredible UI if you really want it to be credible. So yeah, that was it. No questions today,
Okay,
Brian?
I think there's a question. What
Okay.
is the alternative to React JS for this thing? So I think he's asking if there's a alternative to use instead of React
Yes.
JS. Yeah.
Yeah. So apart from React.js, you can use Vue.js. There's also this new framework called Svelte. You can even use that. Svelte is actually getting really popular because it's much easier to handle states in there. So right now here you can see I've done all this extra stuff for using use state to have state variables. But if you use Svelte, you don't really have to do all this. Even normal variables, like if you do constant players and this has some value, then even that is a state variable in Svelte. So yeah, you can use React or Vue.js or Svelte. I don't recommend Angular because that really adds on to the complexity.
Okay, I think that's the last of the questions. So I think yeah, I think we can actually end off here. And any last comments or words from one true? Yeah.
And you guys can always reach me out on Discord if you are watching the recording later on. I will be happy to answer all your questions.
Okay. Okay. Thank you, Anshu, and have a nice day. Yeah. Thank you.
Thank you, Brian.
Bye bye.
Bye bye.